Once the grid itself has been created from our 10 and 30 meter DEMs, this is what our output will look like. This is our terrain correction grid. And if you open up one of the other grids that we imported, that being the 10 or 30 meter regional that we used to create this correction grid, you'll see that it correlates directly to one another. So here's our 10 meter DEM. And if we drag our cursor around, you can see that that also moves the cursor on the 10 meter DEM. So that's how we know that the projection and regridding worked, is that we can move it around and that these are geo-referenced directly, and you can see that here. Now that we've done that, now that we have our terrain correction grid, we can do our terrain correction. So just like everything else, we're going to go to gravity, and we're going to go to terrain corrections, and we're going to go to terrain correction. From here, we're going to populate the correct things here. First one's elevation. Our topography for the top of rock grid, we're going to use our 10 meter local DEM. Our correction distance is going to be 2000. We're going to use 2.67 for the terrain density. Water reference datum is constant. Our water reference elevation is 0. We're going to leave the bathymetry channel blank. Water density 1. And our output terrain, we're going to label this as TC267. And if you ever use a different density, like let's say if we put 1.9 here for a lower density sediment or anything like that, then we would change our output terrain correction channel to TC190 for organizational sake. From here, we're going to input, so there's this little sub menu here that says more. We're going to expand that. And for our terrain correction grid, we're going to input the grid we just created, our TC tutorial grid. That won't be automatically populated, I don't believe. So when you get to this, you're going to click on the 3 dots or pull it up from one of the drop-down menu options. Oops, that's not what I wanted to do. And then one thing I'm still working on that I haven't been able to do yet due to the file size is create our slope channel. So the slope channel is what you're essentially going to do is you're going to take each gravity station that we have, and this is in QGIS, and you have to create a buffer around each gravity channel that contains a suitable amount of pixels. I usually try to put at least 30 to 50 pixels of data within my buffer. So you have to expand the radius depending on the resolution to get a suitable amount of data so that we can extract the slope from the elevation data. And that's just a simple rise over run. And you can populate that slope for each station. It's not the calculation that is currently causing trouble for me. It's the file size and the fact that it crashes QGIS every time. So it might be something that needs to be used in a more robust software, perhaps Arc Pro. Anyway, I am getting off topic. So this is where we have elevation, 10 meter local, 2000, 2.67, constant, 0. The bathymetry channel is unpopulated, water density 1, and our output is TC267. and our terrain correction grid is the grid we just populated or created. We're going to hit OK. And I don't believe this takes too long. And hopefully I'm performing that on the right database. I don't want it to populate in the local. I want it, or location. I want it to populate in the master. Ah, shoot. Okay, well, make sure that you have the active database that you want open. We don't want that one. So in the case of that, there's this little icon up here. It says discard changes, and it just reverts back to the last point in which you saved this particular database. So it's an easy undo if you do that, but that's one thing you have to be aware of that I actually don't do too often, but every now and again it happens. But make sure you have your master database up before you do these corrections, because it's just going to populate the incorrect channel in the incorrect database. Sorry, it would be the correct channel name output, but in the incorrect database. Oh, that's CG6. Okay, I want master, this one. Okay, this is where we want, because we have our bouquet, we have our free air. This is a simple bouquet, so we'll be changing that once we do the complete bouquet, which is with the addition of our terrain correction. Okay, so we're going to go back to terrain corrections again, and we're going to do it on the correct database this time. Everything is populated. We're going to input the other where did I put it? Put in the EM? Yeah, okay. There's our terrain correction, and everything else was automatically populated the way it was. So remember, drop down menu, terrain correction grid, TC tutorial, or whatever you named the grid that you're creating. And we'll wait for this to process again. And this time we'll have an output that we want. And you can see when we go to the bouquet that we will get a slightly different value compared to this simple bouquet, because this is our simple again, and now we're going to do our complete, well, mostly complete. We don't have the slope channel yet, but we'll get there. So we have our free air, we have our terrain correction, and now we're going to go do our free air bouquet anomaly. And the way this one's going to be populated, so the database is the one that we have active, OM master tutorial. Our corrected gravity channel is grav core. Our terrain correction channel is the one we just created, TC267. Our terrain correction density is still going to be 2.67. Elevation channel, elevation. Output free air anomaly channel is free air. This isn't going to change. The free air correction method, 0.30596 milligauss per meter. And we're not going to apply the Bullard B correction, which is essentially correcting for the spherical shape of the slab that we're working with, that we drew out to 167 kilometers. I talked to Professor Louis about this, and he said we don't need to do the Bullard, but in future applications on other projects, perhaps that's something we would want to correct for, perhaps over a larger surface area. A more spherical slab would make sense to correct for, but not for this region. Our output, we're going to call this one output CBA because this is our complete bouquet and we don't want it to confuse it for our simple bouquet. And we're just going to do one correction. If you were to populate this with a different amount or a different number of corrections, let's say we put 2, you'll get another, um, I guess, channel to populate. You'd get your minimum and maximum earth density, and it would run through iterations at each interval. So for 2 bouquets corrections, let's say we put 2.50 and 2.67, we would get 2 outputs. We'd get a bouquet correction at the minimum, and we get a bouquet correction at the maximum, and that would continue to go up. And if we did 10, you would have a minimum and maximum, and then it would run through 8 different iterations between our minimum and maximum values. But we're not going to do that because we only need 2.67 because this single 2.67 density value gives us a good picture in terms of our map of where anomalies are high or low. So we're sticking with 1 for the number of bouquet corrections. We're sticking with water density at 1 gram per cc, and then ice density is 0.92 is what we're going to be using for that. We're going to hit OK, and then we're going to have our bouquet corrections here. So it looks like actually this populated here is the same thing. So it looks appears that it does the simple anyway, populates that channel, adds our terrain correction, and then outputs our complete bouquet. And the reason we're adding this is because in the actual formula, there's a distributive negative sign that changes this negative value that we're subtracting to a positive. And that's why we're adding the terrain correction to our complete bouquet. So there's our complete bouquet. That's pretty much everything you need to do before you want to grid and image this. And I know you're already familiar with this, so we'll just do that real quick. Data to grid. We want CCBA, management curvature 460. You can mess around with the cell size on this one. Maybe 150. Whoops. 150 would be good. Yeah. And we'll hit OK. We'll do the map tools, contour, quick. Yes. Okay. Okay. And then we'll give our quick contour like that. That doesn't look great. It's not, I must have just quickly clicked on the wrong grid. But you know the steps for gridding and putting our stations on there. And that's pretty much the entire walkthrough from creating or manipulating our data all the way through to a complete bouquet minus the slope, unfortunately, to populating a complete gravitational anomaly map for the Reno Basin area. The next thing we're going to tackle is GEMSYS and doing a 2D profile model along a transect on the map, and then matching that to lithologies along the way and seeing how these gravitational anomalies match up with the lithology. And then following that is importing seismic data into GEMSYS to profile the velocities with our gravitational anomalies and see how those both correspond to the mapped lithology of the Reno Basin area, and look for correlations between all of our variables. All right, I think that about covers it.